Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in this session. So, let us start our session. Children, can you identify the type of triangle shown on your screen? Yes. Here if you notice, both the sides of a triangle are equal. Such type of triangle? Yes, it is an isosceles triangle. Now, what are the properties of a triangle, children? Do you remember them? Yes. The first one is the sum of all angles in a triangle is 180 degrees. We call it as angle sum property of a triangle. And angles opposite to equal sides of an isosceles triangle are equal. And sides opposite to equal angles of a triangle are equal. So, apart from this, you have few more also, right children? Yes. What do you notice on your screen, children? Yes, we have 4 points A, B, C and D. Let us join these points, children. What did you get? Yes, a straight line passing through all these points A, B, C and D, right children? Now, these points A, B, C and D are called collinear points. Why these are called collinear points? Because all these points lie on a same straight line. So, that is why we call these points as collinear points. Now, children, let us consider these points are not collinear. That means, they are not on the same straight line, right children? Now, let us join all these points once again, children. Yes. Now, what do you notice, children, here? And can you identify the figure formed here? Yes, here you got a figure which is formed by joining 4 points. It is a simple closed figure with 4 sides. It is called a quadrilateral. Do you know the different types of quadrilateral and its properties, children? We are going to learn about these quadrilaterals and its types and properties in our topic quadrilaterals part 1. So, by the end of this session, you will learn different types of quadrilaterals, properties of quadrilaterals and also parallelogram and their properties. So, first we will start with different types of quadrilaterals. So, here you notice a quadrilateral ABCD, right children? Yes. How do we define this? It is a simple closed figure formed or bounded by 4 line segments in a plane. Okay, children. Now, what do you notice from this quadrilateral ABCD? Yes, it has 4 sides. What are the sides, children, here? Yes, AB, BC, CD and DA. So, these are the 4 sides. And what else? 4 angles. What are the angles, children, here? Yes, angle A, angle B, angle C and angle D. What else, children? Yes, 4 vertices. So, what are the vertices? Yes, A, B, C and D are the 4 vertices. Now, apart from this, you notice there are 2 diagonals. What are the diagonals here, children? Yes, let us draw them. We will join vertex B and D, that is opposite vertices. So, BD is one diagonal. Similarly, AC is another diagonal. So, on the whole I can say a quadrilateral has 4 sides, 4 angles, 4 vertices and 2 diagonals. Okay, children. Let us see the properties of this quadrilateral. The first one is the sum of 4 angles in a quadrilateral is 360 degrees. So, which we call it as the angle sum property of a quadrilateral. Okay, children. Now, here we notice a quadrilateral ABCD and diagonal BD. Now, this diagonal divides it into 2 triangles ABD and ACD. Can you notice, children, here? What are the 2 triangles here? Yes, here is ABD and BCD. This is another triangle. Okay? So, we have 2 triangles which this diagonal has divided the quadrilateral into, right? And we know the angle sum property of a triangle which states the sum of 3 angles in a triangle is 180 degrees. That means, if you notice the first triangle, that is ABD. So, ABD, if I had angle A and this angle, that is angle ABD, and this angle BDA, it is equal to 180 degrees. Now, what about this triangle, children? Yes, even in this triangle also, if I add all these three angles, I should get 180. So, let us add them. So, that is angle BDC, angle C, and this is angle CDB. So, on adding this also three angles, we get 180. Now, let us add these two angles, children, that is angles of first triangle and angles of second triangle. So, on adding them, you get 180 plus 180 in RHS. So, I will write angle A as it is in LHS, and notice angle ABD plus angle DBC. So, angle ABD. So, this part, that is this angle, and angle DBC, this part. So, if you add these two parts, what do you get, children? This total part. This total part is nothing but angle B. So, sum of these two angles is angle B. And angle C as it is, children, we are not going to change. Angle C as it is we are writing. Then there are two more angles left here. There is angle BDA and angle CDB. So, angle BDA, that means this part, and angle CDB means this part. So, if I add these two parts, what do you get, children? This total angle, that is angle D. So, I get angle D. The sum of these two angles 180 plus 180 is 360. So, that means angle A plus angle B plus angle C plus angle D is 360 degrees. Hence, I can say the sum of four angles in a quadrilateral is 360 degrees. So, this is the angle sum property of a quadrilateral. Now, let us move on to the types of quadrilaterals. Now, here also we have a four-sided figure, a quadrilateral, right? Here this one, it is a four-sided figure, it is a quadrilateral, but in this quadrilateral, you will notice that one pair of opposite sides, that is AB and DC, are parallel to each other. Such type of quadrilateral is called a trapezium. So, how do we define trapezium, children? Yes, a quadrilateral in which a pair of opposite sides are parallel is called a trapezium. So, this is one type of quadrilateral. Let us move on to our next type. So, let us take a special case of a trapezium. Okay, children. So, in this trapezium ABCD, here AD and BC both are equal. So, what are AD and BC, children, here? Yes, these two are non-parallel sides, right? Only these one pair of opposite sides are parallel, then these two pair of sides are non-parallel sides. Now, whenever the non-parallel sides of a trapezium are same or equal, we call it as an isosceles trapezium. So, how do we define, children? If in a trapezium non-parallel sides are equal, then it is called as an isosceles trapezium. Let us consider the next type of quadrilateral. So, here again we have a quadrilateral ABCD, but here we can notice AB is parallel to CD. So, here opposite one pair of opposite side, that is AB and CD both are parallel to each other, and also we have AD parallel to BC. That means both the pairs of opposite sides of this quadrilateral are parallel. Now, such type of quadrilateral is called a parallelogram. So, how do you define, children? A quadrilateral in which both pairs of opposite sides are parallel is called a parallelogram. Let us move on to our next type. So, I am taking a quadrilateral, and here this quadrilateral is nothing but a parallelogram I am considering. Now, this parallelogram ABCD, in which all angles, if you notice, angle A, angle B, angle C, angle D, all are equal. That means all angles are equal means each angle is 90 degrees. So, angle A is equal to angle B is equal to angle C equal to angle D equal to 90 degrees. So, such type of parallelogram, okay, it is actually a parallelogram, which is one type of a quadrilateral. Now, this type of parallelogram is called a rectangle. So, how do you define a rectangle, children? A parallelogram in which all its angles are equal is called a rectangle. So, already parallelogram means opposite sides are equal. Apart from that, if all the angles are also equal and equal to 90 degrees each, we call it as a rectangle. Let us move on to our next type. Let us consider a quadrilateral ABCD in which all the sides are equal, that is AB equal to BC equal to CD equal to DA. Now, such type of parallelogram is called a rhombus. So, how do we define rhombus, children? A parallelogram in which its adjacent sides are equal is called a rhombus. If you notice, this is a parallelogram in which only the opposite sides are equal. Suppose if these two adjacent sides are also equal, then it becomes a rhombus ABCD. Okay, children, that means in rhombus all four sides are equal. Let us move on to our next type of quadrilateral. Again, I will consider a parallelogram, okay, ABCD, in which again all the sides are equal, that is AB equal to BC equal to CD equal to DA, and apart from that I will consider all four angles, that is angle A, angle B and angle C and angle D, all are equal. So, since they are equal, that means each is 90 degrees. So, such type of parallelogram is called a square. So, how do you define a square? A parallelogram in which its adjacent sides are equal and all its angles are 90 degrees is called a square. So, in this parallelogram the adjacent sides are equal and also all the angles, all the four angles are equal and they are equal to each 90 degrees, then we call it as a square. Let us move on to our next type, that is again a quadrilateral we are considering ABCD. Now, in this quadrilateral ABCD, adjacent sides, that is AD is equal to CD. So, we have AD and CD both are equal, and also we have other adjacent pair, that is AB and BC, they are also same. Now, such type of quadrilateral is called a kite. So, a quadrilateral in which two pairs of adjacent sides are equal is called a kite. So, children, we have learned what a quadrilateral is and also we have learned the different types of quadrilaterals. Now, based on these concepts that you have learned, let us see a few concepts and try to answer them. Okay, children. Children, can you say a rhombus is a square, but all squares are not rhombuses? Yes, you are right. We cannot say that a rhombus is a square, because a square is a rhombus, because if all sides are equal, it is a rhombus. So, in a square all sides are equal, but a rhombus is not a square. Why? Because in a square all angles also should be equal and equal to 90 degrees, but in rhombus all the angles are not equal and they are not equal to 90 degrees. So, that is why a rhombus is not a square, whereas a square is a rhombus. Similarly, all rectangles are parallelograms, but all parallelograms are not rectangles. So, these are very important concepts, children, that you need to remember. Okay. So, let us learn about the properties of parallelogram, children, now. So, the first theorem states a diagonal of a parallelogram divides it into two congruent triangles. This is the statement of the theorem. So, let us draw a parallelogram ABCD. So, what is given, children? Yes, ABCD is a parallelogram and AC is the diagonal. So, this is given to us, children. So, while answering theorems, so first you need to write the hypothesis, that is the given part. So, ABCD is a parallelogram in which AC is the diagonal, and what you are going to prove? This diagonal divides it into two congruent triangles. That is what we have to prove, right, children? So, write down to prove triangle ABC and triangle ADC both are congruent. So, here the diagonal is dividing it into two triangles, right, children? So, here ABC is one triangle and ADC is another triangle. Now, these two triangles are congruent to each other. That is what we have to prove. Okay, children. So, here if you notice, AB is parallel to BC. So, here in this AB and CD both are parallel to each other, and I can write angle DCA is equal to angle CAB. So, you can notice from the figure, angle DCA and angle CAB both are equal, and at the same time you have other pair of opposite side, that is BC and AD are parallel. Again I can write angle BCA is equal to angle CAD. Why these two angles are equal, these two pairs of angles are equal? Because they form alternate interior angles, and also notice that AC equal to AC is the common side. So, therefore, what we can write, children? Yes, triangle ABC is congruent to triangle ADC. So, how can we say these two triangles are congruent? Here two angles and the included side. So, we can say that by ASA congruency both the triangles are congruent. So, I can say that the diagonal of a parallelogram divides it into two congruent triangles. Okay. Now, let us move on to our next property. In a parallelogram, opposite sides are equal and opposite angles are equal. So, again let us consider parallelogram ABCD. Now, in this what is given? Yes, simply a parallelogram ABCD with AC as a diagonal. Now, what is needed to prove? Yes, opposite sides are equal. That means, AB equal to CD and AD equal to BC. Then we have to prove even the opposite angles are also equal. That is, angle A equal to angle C and angle B equal to angle D. Now, let us see the proof. So, we have already learnt in the first theorem, right? The diagonal of a parallelogram divides it into two congruent triangles. We have AC as a diagonal, and this AC diagonal divides the parallelogram into two congruent triangles, that is triangle ABC congruent to triangle ADC. Okay, children, that is what we have proved in the first theorem. Okay. So, since they are congruent by CPCT, so what do you mean by CPCT, children? Yes, corresponding parts of congruent triangles. So, by CPCT we have AB is equal to CD. That means, this AB and CD both are equal. Okay, children. And also I can write the second congruent part, that is AD and BC both are equal by same CPCT, and angle B and angle D both are equal. So, angle B is equal to angle D. This is what we write by CPCT. Okay, children. So, from this we have proved the first part, right? That is, opposite sides are equal. So, the first part is over, and in second part also we have proved one, that is angle B and angle D are equal. So, only what is left now? Angle A should be equal to angle C. This is what we have to prove. Now, let us prove that one also. So, let us mark this angle, that is angle DCA, and this angle as CAB. So, both are equal, right? Why these two angles are equal, children? Yes, because they are alternate interior angles, and even these two are also equal. Why? They are also alternate interior angles, because BC parallel to AD and AC is a transversal. These two are alternate interior angles. Similarly, AB parallel to CD and AC is a transversal, and these two green color angles, they are also equal because they are also alternate interior angles. Okay, children. So, we are writing that. Now, from these what I do is I will add them, like I am adding DCA plus BCA is equal to BAC plus DAC. Now, let us see what do you get. So, DCA plus BCA, DCA this part, and BCA, BCA, so this part. So, sum of these two is what? Angle C, right? That is, I can write DCB. Then we are adding, so BAC this part, green part, and DAC, DAC is again this part. So, sum of these two angles is what? This one, A. I can write that as angle DAB. So, now we have proved angle A and angle C are also equal. So, hence I can say opposite sides are equal and opposite angles are also equal. So, let us move on to our next, say, property of parallelogram. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So, let us understand this. So, each pair of opposite sides of a quadrilateral. So, quadrilateral ABCD is given, okay, and in this we have AB and CD both are equal, okay, and also AD and BC are equal. So, both the pairs of opposite sides are equal. Now, whenever both the pairs of opposite sides are equal in a quadrilateral, that quadrilateral becomes a parallelogram. So, this is the theorem 3. So, let us move on to our next theorem, that is 4. In a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. So, let us consider a quadrilateral ABCD. Now, in this opposite angles are equal, that means angle A and C are equal and angle B and D are also equal. Now, whenever you have such opposite pairs of angles are equal in a quadrilateral, then that quadrilateral becomes a parallelogram. Okay, children. Now, let us move on to our next theorem, that is the diagonals of a parallelogram bisect each other. Now, let us prove this. So, consider a parallelogram ABCD. Okay. Now, in this AC and BD both are diagonals intersecting at O. So, given parallelogram ABCD, AC and BD are diagonals intersecting at O, and what we have to prove, children? Yes, the diagonals bisect each other. So, what do you mean by bisecting, children? That means this point O, okay, is exactly midpoint of AC and also it is midpoint of DB or BD. That means I have to prove OA equal to OC and OB equal to OD. This is what we need to prove. Now, let us prove that, children. So, let us mark these angles 1, 2, 3 and 4. So, as you can see on the screen, we are marking angle 1, angle 2, angle 3 and also angle 4. Okay, children. Consider triangles OAB and OCD. OAB, this triangle, and OCD, this triangle. Now, these two triangles if we consider, I can write angle 1 is equal to angle 3, angle 2 is equal to angle 4. But why these two angles are equal, children? Yes, because they are alternate interior angles. Not only that, AB is equal to DC. Why AB and DC both are equal? Because it is both are opposite sides of a parallelogram. Now, I can write both the triangles OAB congruent to OCD. Why? If you notice, in these two triangles are equal and the included side of this triangle are equal to two angles and included side of another triangle. So, by ASA congruency criterion, I can write these two triangles are congruent. So, both the triangles are congruent, you got. So, by CPCT, what do you get? Yes, I get the corresponding parts are equal, that is OA and OC are equal. Then what is the other congruent part, children? Yes, OB and OD, they are also equal. That means, I can say that the diagonals of a parallelogram bisect each other. Let us move on to our next theorem, children. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So, we will consider a quadrilateral ABCD in which diagonals AC and BD intersect at O and they bisect each other. Bisecting means just now we have seen it divides, like OA is equal to OC and OB is equal to OD. Then in that case we can say that that quadrilateral is a parallelogram. Got it, children? So, children, till now we have learnt what actually a quadrilateral is and also the different types of quadrilaterals and also the properties of quadrilaterals as well as parallelograms. Now, let us apply these concepts that we have already learnt in solving few problems. Let us start with the first problem. Show that the diagonal of a rhombus divide it into 4 congruent triangles. Let us start with the solution. So, let us consider a rhombus ABCD and diagonals AC and BD, both are intersecting at O. Okay? And the diagonals of a rhombus bisect each other perpendicularly, that we have already learnt as one of the property of a rhombus. Okay, children? That means, I can write OA equal to OC and OB equal to OD. So, that is the meaning of bisecting each other, right, children? We have already learnt. Also, I can write all the sides are equal in a rhombus. That means, all these 4 sides, that is AB, BC, CD and DA all are equal because it is a rhombus. Okay, children? Now, in triangles AOB and COB, that is triangle AOB and COB, these two triangles, if you consider these two are adjacent triangles, right? In these two triangles, AB equal to AC. So, here if you notice, AB and AC both are equal because they are sides of rhombus, and also OA equal to OC. We have already seen here, right, because diagonals bisect perpendicularly, and this OB is there, which is a common side for both the triangles. So, I can say these two triangles, that is triangle AOB and COB, both are congruent by which property, children? Yes, SSS congruency, because 3 sides of one triangle are respectively equal to 3 sides of another triangle. Therefore, both the triangles are congruent. So, we got 2 congruent triangles. Let us mark it as equation 1. Now, let us consider triangle COB and COD, that is COB, COD. Okay, children. So, in these 2 triangles, again if you notice, I can write, yes, BC equal to CD, that is BC and CD both are equal because they are sides of rhombus, and OB and OD both are same because diagonal bisect each other, and here OC is equal to OC because it is a common side. So, what can we say children again? Yes, we can say these two triangles, that is COB and COD, both are congruent to each other by again SSS congruency. So, similarly we can prove COD congruent to AOD, that is this COD is congruent to this AOD. So, this also we can prove it. So, mark this as equation 2 and equation 3. Now, from all these equations we can write, that is equations 1, 2, 3 and 4, we get triangle AOB congruent to triangle BOC or COB, this is congruent to triangle COD and this is congruent to triangle AOD. That means, all these 4 triangles are congruent to each other. So, children, we have proved that the diagonals of rhombus divide it into 4 congruent triangles. Okay, children, let us move on to our next problem. The 4 angles of a quadrilateral are in the ratio 1:2:3:4. Find the measure of each angle of the quadrilateral. Let us start with the solution. Given angles are in the ratio 1:2:3:4. So, let us assume these angles as x, 2x, 3x and 4x. Sum of angles in a quadrilateral is 360 degrees, that is angle sum property, right children. That means, on adding all these, that is x plus 2x plus 3x plus 4x, we should get 360 degrees. So, on adding all these, what do we get children? Yes, we get 10x. So, adding all these things, 10x is equal to 360. So, what is the value of x? Right, 360 by 10, we get 36. So, let us find the value of 2x now. 2x is 2 into 36, 72. And what about 3x? Yes, 3 into 36, 108. And finally, we have 4x, that is 4 into 36, we get 144. So, the 4 angles are 36 degrees, 72 degrees, 108 degrees and 144 degrees. So, children, till now we have learnt the applications of the concept that we have learnt about quadrilaterals, types of quadrilaterals and properties of quadrilaterals. Okay, children. Now, before we end our session, let us quickly recap what we have learnt in this session. A quadrilateral is a simple closed figure formed by 4 line segments in a plane. The sum of 4 angles in a quadrilateral is 360 degrees or 4 right angles. A quadrilateral in which one pair of opposite sides is parallel is called a trapezium. A quadrilateral in which both pairs of opposite sides are parallel is called a parallelogram. A parallelogram in which all angles are right angles, or I can say it is 90 degrees, is called a rectangle. A parallelogram in which its adjacent sides are equal is called a rhombus. A parallelogram in which its adjacent sides are equal and all angles are equal is called a square. A diagonal of a parallelogram divides it into 2 congruent triangles. The diagonal of a parallelogram bisect each other. The diagonals of a rhombus bisect each other perpendicularly. Diagonals of a rectangle have equal length, and finally, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now, it is time for us to work out some problems on the concepts that we have learnt. Let us see those problems. In a parallelogram ABCD, angle ABC is 110 degrees. Find the other angles of the parallelogram. The opposite angles of parallelogram are 3x minus 12 degrees and x plus 28 degrees. Find the measure of each angle of the parallelogram. Prove that in a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. The 4 angles of a quadrilateral are in the ratio 2:3:5:8. Find the measure of each angle of the quadrilateral. So, children, with this we come to the end of our session. I hope you have learnt all the concepts perfectly. So, children, we have learnt all the concepts and also we have applied these concepts in solving few problems, and I want you all to submit your assignment to your subject teacher. So, with this we come to the end of our session. We will meet in our next digital class. Until then, goodbye and take care.